May the 15th, 2017. As we watched the last few months, intense energy come from our sun, especially through the coronal holes like we're seeing today. We've got double the solar wind speed now at about 1.3 million miles per hour. At 1300 hours today, and I'll show you the chart, as that impact hit, we had the 6.2 earthquake within minutes. It was very obvious we had a sudden impact. Again, I'll show you the charts. But what happens when that energy is continually feeding into our planet's core via the magnetic lines of force that create our Earth's shields? That continuous buildup creates heat in what's called our magma layers, or magma zones, in the transition zone. What they're talking about now, and I want to mention this, is that Italy's supervolcano, which is called Campi, Flegrei, is at a critical stage in the build-up to a devastating eruption. And this one erupted about 500 years ago, was the worst one in modern history, but it goes back to 12,000 years ago. Think about that, guys. We've talked about 12,000 years ago a couple times. But they say that, again, Campi Flegrei is a critical stage. It is a supervolcano located outside the western suburbs of Naples. Its last devastating eruption was 1538, following a century of unrest. The volcano had been restless. It has been restless again since 1950. So what we're dealing with is 67 years of pressure buildup. And what happens with this particular volcano, unlike the one, say, in Hawaii, is the ground will suddenly rise, and it's been rising, and it's starting to crack. They're saying that it has built up the energy in the crust that is very similar to what the archaeologists have looked at as far as the crust displacement in 1538. If it does erupt, experts believe it would affect 360,000 people living across the caldera and Naples' population of nearly 1 million. You're looking at a map of that now. It says, by studying patterns of unrest over the last 500 years, the researchers have predicted that we're reaching a critical stage where further unrest will lead to an eruption. Now, keep reminding folks that we're in weather chaos right now. The climate is shifting. We are tilted further to the sun than we're supposed to be. And that's because of the earthquake starting in 2004 in Sumatra. And then it just elevated with the quake in Chile, and 2011 with the quake in Fukushima. Showing you those charts. And over the weekend, guys, there was record snow in the northern United States. 5 to 7 inches in places. Just came out of nowhere. That Arctic vortex is so far out of whack that it's throwing hot weather, rainy weather, cold weather all around the northern hemisphere. And because of the extreme tilt, it just magnifies that. But what happens every time they show an ice age, like the Martyr Minimum and things like that, and the last ones, is that volcanic activity seemed to be connected. In other words, just as things were getting bad, a large volcano would erupt, put a lot of ash into the atmosphere, block the sunlight, and make it even cooler. Many ash falls that they've studied coincided with these ice ages, or colder periods where crops didn't grow. It was very little summer. People had to migrate. People died. Experts from UCL and the Vesuvius Observatory in Naples, which Vesuvius is just across the bay there, guys, studying the patterns of the unrest since Campi Flegrei's last eruption 500 years ago, and they're saying that it has been restless for 67 years with 2-year periods of unrest in the 50s, 70s, and 80s, calling small local earthquakes and ground uplift. And that's what they're watching for, a certain height on this ground rising, because they're saying that this magma is not deep at all below this place. Using a new model, the researchers investigated whether Campi Flegrei may again be preparing to erupt. They found the unrest since the 50s has been causing a buildup of energy in the crust and making the volcano more susceptible to eruption. Until now, scientists had thought the energy needed to stretch the crust was lost after a period of unrest. And when you go to solar maximum, you see stronger coronal mass ejections and solar flares, but this continuous solar wind that's doubling and tripling coming off the sun, and now today the proton density has been incredible. Usually that goes way down during these high events. But when you have that proton density, that's just more energy being fed into the core of the Earth. But during those solar maximums, we don't have as many volcanoes, again, because we see more quakes because of the sudden impacts. But the steady heat has already been noted in other volcanoes around the planet. Dr. Kilburn goes on to say, by studying how the ground is cracking and moving at Campi Flegrei, we think it may be approaching a critical stage where further unrest will increase the possibility of an eruption, and it's imperative that the authorities are prepared. The episodes of unrest are caused by the movement of magma around 3 kilometers below the volcano. Guys, that's not very far at all, because your magma transition zone doesn't start to around 200 to 400 kilometers. It says this is because the molten rock can escape to the surface when the ground splits apart. An eruption comes more likely when the ground has been stretched to its breaking point. And this is classified as a supervolcano, only one level below the Yellowstone eruption, guys. Think about that, the largest eruption known on the planet. It says, although it hasn't erupted, unrest at the volcano has already caused severe social disturbances at Campi Flegrei. Now, the 3 episodes we mentioned, the 50s and the 70s and 80s, they created an uplift that has pushed the port of Pozzuolo, which is right in the center of Vesuvius and Campi Flegrei, says it has pushed the surface up 3 meters out of the sea, about 10 feet. Dr. Stefan Colino, who also worked on the study, said the unrest in 70 and 83 caused tens of thousands of people to be evacuated from the Pozzuoli area itself. It covers more than 100 square kilometers. This volcano is like Yellowstone. It's not that big, but it's not a cone anymore. That's blown apart. That's 38.6 square miles, and you've got 40 or 50 vents. But guys, this place has a lot of history. It was the land of the giants. It's where, according to the Greek and Roman myths, that Hercules defeated the giants. And it's also called the place that holds the gates to hell. Look at this picture. Now, this area, a volcano system, has a colorful history. They're saying the Romans thought an area called Solfatara, where gas is emitted from the ground, was the home of Vulcan, the god of fire. Meanwhile, one of the craters in the system, Lake Avernus, was referred to as the entrance to Hades in ancient mythology. And again, I mentioned it's not listed here, but that's where they said that Hercules defeated the giants. And we know that the giants existed there in the Bible. Now, here lies our problem. It's this large coronal hole that we're seeing now. I talked about it yesterday, and that we would be getting the solar wind increase, and we are getting that. We've had a couple of coronal mass ejections or filament releases from the sun too, but less than a week apart now, these 2 coronal holes. We were seeing them every 2 weeks. Check this out. Now, what's amazing is right behind the sunspot, we see another opening that's being created. That means within the next week, we could have 3 different pulses of this extreme high solar wind. Again, we talked about this. If you have a slow rise in the solar wind, you'll see the 5s and low 6s start popping off. But what happens during that slow feed is these volcanoes heat up. But if you see an impact like we did today at 1300 hours, where a sudden rise comes in, you start to see the stronger than the 6 quakes. And we had that. Again, perfect timing as it hit. I'll show you the charts. I'll show you the earthquake maps. But we've had a coronal mass ejection, and they're watching it here. Now, what the chart does not show, be aware of this, is the coronal hole and the solar wind stream that we're going through now. This was a CME that left the sun. Check, we will back it up right here on the 14th when we saw that explosion. Now, as I advance this out, they're showing the impact as far as plasma density in the top chart in the green. And it's supposed to hit us in the late hours of tomorrow on the 16th. And it's showing that the radial velocity, which is solar wind speed, in the bottom graph, guys, in the green line, is around, at this time, 350, which starts and rises up to about 550 The problem is it's already above 550. We're in 600 now. This model was not predicting the solar wind speed. Now, since I was doing the video, it's increased by another 100 kilometers per second. But at 511 to 550, you're at 1.23 million miles an hour. But notice the timestamp at the bottom, 1200, and then you got 3 lines between there and 1600 hours. That is 1300, 1450. So right after 1300 hours, when we saw this first impact wall, at 1322, we had the 6.2 earthquake down in Papua New Guinea. This is exactly what I talked about last night. If you have the slow rise, you won't have these. But guys, we're just kind of getting into the solar wind stream now. And as I looked a few moments ago, we're again over 600 kilometers per second. And you can see it as it's coming into the magnetopoles. This is the Earth's shields. The sun's energy is coming from the right. The sun is in the center. It's building up over the day, and you'll see a double wave build up as we get closer and closer to 1300 hours. Right there at 900, and it continues to push in. As that energy collapses, our Earth shields compress around our planet. As we approach 1300 hours in the timestamp at the top, this is going to compress further and further in towards our planet, and you'll see the waves build up behind it, and the pressure build up, and it compresses the Earth's atmosphere. But guys, we're watching this. We're watching Hanford. The rates there are slightly elevated. They're not super high, but we got more and more people coming online, and I hope to update that in a couple of hours. We're watching this, guys. It's a heads up. Be safe. Of unrest. The volcano had been restless. It has been restless again since 1950. So what we're dealing with is 67 years of pressure buildup. And what happens with this particular volcano, unlike the one, say, in Hawaii, is the ground will suddenly rise, and it's been rising. And it's starting to crack. They're saying that it has built up the energy in the crust that is very... And this one erupted about 500 years ago. Was the worst one in modern history, but it goes back to 12,000 years ago. Think about that, guys. We've talked about 12,000 years ago a couple times. But they say that, again, Campi Flegrei is a critical stage. It is a supervolcano located outside the western suburbs of Naples. Its last devastating eruption was 1538, following a century of May the 15th, 2017. As we watched the last few months, intense energy come from our sun, especially through the coronal holes like we're seeing today. We've got double the solar wind speed now at about 1.3 million miles per hour. At 1300 hours today, and I'll show you the chart, as that impact hit, we had the 6.2 earthquake within minutes. It was very obvious we had a sudden impact. Again, I'll show you the chart. Similar to what the archaeologists have looked at as far as the crust displacement in 1538. If it does erupt, experts believe it would affect 360,000 people living across the caldera and Naples' population of nearly 1 million. You're looking at a map of that now. Says, by studying patterns of unrest over the last 500 years, the researchers have predicted that we're reaching a critical stage where further unrest will lead to an eruption. But what happens when that energy is continually feeding into our planet's core via the magnetic lines of force that create our Earth's shields? That continuous buildup creates heat in what's called our magma layers, or magma zones, in the transition zone. What they're talking about now, and I want to mention this, is that Italy's supervolcano, which is called Campi Flegrei, is at a critical stage in the build-up to a devastating eruption.